This
Taking time.
conference will now be recorded.
Right. So we're going to talk about table partitioning in Postgres. So we have three different types of table partitionings. Okay. We're going to go through all that. So how it works, how it will be helpful, how good in terms of performance, and what are the situations we call it different types of partitioning. All that will be covered. Just focused. So we have three types of partitioning in Postgres. Generally, uh, range-based sharding, we do range-based partitioning is the one which we hide mostly used. Okay, range-based partitioning. Then you see the list-based. Then you see the hash-based partitioning. So we'll go through one by one. So range-based, when we go with basically when we read the range queries, like you want to read the data between the dates, between the range, some kind of thing, then we go with the range-based. So mostly people use the range-based partitioning compared to other two. Um, let's go through how it will be done, kind of. Generally, range-based partitioning will be used against a range of values and dates. Generally, this is what we do. So let's go through the practical implementation, how it will be done, how it will be helpful. Everything we will see in practical. Try to follow. I'm going to cover a lot many things here. Oh, this is the issue. You see this hyphen L is not started yesterday. It worked, right? This is a problem in 17. List of database. Okay, that's okay. So select. We can use this one asterisk from PG database. We can find database list here as well. Just that name. Okay, I'll connect to another database just for the use case. So class, and we have only one table. I'm dropping it that also. Drop table student. We'll create partitioning table. Okay. So I'm going to create the table. Create table student. Okay, and define the table s number integer s name varchar 100 s address varchar 100 partitioned by, we have to define when we are creating the table itself, partitioned by range and what column s number. I want to define the field on which we're going to partition. So this is a table. If you look at it, it will show that partitioned table. You can clearly see that. Now under that table, we're going to create the partition to divide the data. To when it loading the data into table, it should be loaded into respective partitions. We have to define the ranges on the table. So let's create the partitions. It is also independent tables, but we will attach to that. Create table, maybe cust partition one, partition one underscore student. Okay. Partition of, I'm going to create the partition of student attaching. See, this is a table name partition of student for values from 1 to, I wanted to make it to 100. This is, if the value comes in between, it should come to this partition. Then next partition, let's create few partitions and play around. Okay, 2, I'll make it 101, here 200, then partition 3, here 201 to 300. Just we are taking sample ranges. It can be bigger ranges in the real time based on the data. Okay. Partition 4, this is enough. Let's load the data after it. Right. I'll make the notes, don't worry. So now we created 4 partitions here for the table student. You can see that. So you created a table called student. It has the 4 partitions under that table. When we are creating the tables, these partition tables, we are not actually defining any structure. The structure is inherited from the parent table, what we created under student. So we created see, the table when we created it is a partition table by range, and we are creating the partitions of the student. And for values, what are the values we defined? It is clearly showing it 1 to 100, 101 to 200, or 201 to 300, 301 to 400 clearly. Now if I insert any data, example, insert into, you see application side, data comes into student only, this one itself. Then don't touch the underlying partitions manually. Generally they don't know. In fact, as a logical, this is a logical object, these are all physical tables under the partition table. In fact, this is won't create any physical file as well. These tables will hold the actual data, and they will be mapped under the student table automatically, physically mapped. Okay. But this is a logical object student. If you want me to show that quickly, that will, this table will not have any physical file. Select pg relation file path, there is one thing. This is out of topic anyway, but this is not a physical object. Partition tables are logical, purely logical. You don't have a physical file. But if you go to this one, all these files will have the physical files. The actual data will sit in the partition tables. You can see that partition table has a physical file where data loads. The actual table, the parent table, is absolutely logical. They won't have any physical storage. It won't store anything except tagging the table. You're tagging the tables under the parent table. Okay, fine. Let's load some data and play around. Insert into student values. So here example, I'm giving it Dolly. Yes. So I'm loading some data. Okay. So where I'm using the student, I'm not touching the partitions at all. Then I'll make it here maybe 45, then 60 something, then 101, 121, 21, 251, 300. Random data. Okay. If I load 450, it will go out of range. This I'll cover a little later on. We'll talk about out of range data, how it handles. So now if I go and read the data, student, you see the data like this. But each range of data physically where it went. So if you go and check the student, if I go and read each one here, come on, select asterisk from, data got divided physically in the background. This took 145, 60. Second one between 101 to 200, automatically data will get segregated. Okay, because we did that logic during the partition creation. You can see that 101, 21, 51. Now if I go to here 3, we have this. If I go to 4, we have this. See, if I read the data example, how it actually defines or improve the performance, I'm reading the data student, okay, where S number between 1 and 100 example. This is a range kind of read. If I read this, it will get this one, but in the background It is going to read, explain, analyze, where we can see how it is executed. If you can see, it is reading partition one only to read the data. It is not touching the entire partition set to get your data out. So physically, it is only touching the portion of the data of the table. That's how it improves the performance. Like many times, if you are having huge data, you did all your indexing, you did everything what you can do, still you see the performance gain. If you want to do further, you can do the table partitioning. Table partitioning is the highest thing that you can achieve the performance on the tables and the large, especially when the dealing with the huge data. Table partitioning, one thing we need to consider to improve the performance a lot. If you see here, I'm giving it only one partition scanned. If I go with the between 200 1 to 200, it will scan two parts. In fact, partition 1, you can see that partition 2 and partition 1, only two partitions are scanned. Why not other partitions it is not scanning? Because it knows where your data is actually falling under. It's not touching entire table physically all files. It is only knows that your range is falling here and here only. It goes to those files only. So it is limiting your number of records that it has to scan, even if it has to scan. This is how actually it improves the performance a lot in the background when you are going with a huge range of data when you are reading it on the large tables. Getting? Yes, no? It's straightforward, in fact.
I was getting, but example,
Good.
I have a table, but in the future it was grown into like a n number of tables, n number of rows are there. Can we redefine that table with the partitioning? Uh,
Yeah, of course. Why not? You should, in fact. That's how I'll manage. I'm going to talk about that. Good question, in
okay.
fact. So this is the one. What he's saying is a very valid question. You defined these many partitions. Those partitions also becoming bigger. I wanted to introduce even more number of partitions to even further partition the data. That's what his question, right? Is it the one?
No, 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 no. It's already
Hmm.
existing table. We are not at the time of the table definition. We are not did the partitioning. So in future we want to be implement this technology and this
Uh-huh.
concept in
See, what you
table.
have to do, you have to create the empty table with all partitions. Okay? You have to load the data into that partition table. Then it will segregate your data. So how you will do it? I quickly explain. Okay? Question is good. So
Okay.
so it's simple, guys. What I'm going to do. If we have to do such things. So copy the data. Copy when it is a table is partitioned. Let's take one location where I can take the race data quickly. I mean, that's not a bigger discussion, so but still, I want to show that how you define your partition table, how you load the data into partition table to get the data distribution done. You created your table, but you did not partition in the beginning, as you said, but later on you realized you want it. So here I want to take the copy export. I want to export the table. So if I use a copy table student to this is how we take the data export. In fact, okay, student dot txt delimit. I talked about this already. Okay, so
Yeah.
delimiter here I'm taking it. Okay, it will throw the error basically. Delimiter. Sorry. So basically, you have to, whenever the table is partitioned, you can't call the table like that. You always have to use, this is a condition for the partition table, not normal table. You have to call like this, select asterisk from student. You have to use like that. So what it is actually doing, it is generating the entire data into physical file. Okay, your actual table data, this one, think like that. So you created a partition table, student. Now I'm going to load the data. Copy student from where? From this location, entire location. So you create your own partition with the number of partition that you want, number of ranges you want to define. You export and import in that table, it will partition your data automatically. Now you go and check your data is loaded into this table. Getting data got loaded. I just shown that it's non-partition kind of thing that way. You export and import to the partition table, you got the data partitioned.
Okay, got it.
Getting? So that's how it is. If you don't have a partition, but you want to build, first create a empty table with the number of partition that you required. You want to divide it, and then export and import and load the data. This is a kind of a downtime. You should not touch the source table because you should have 100% data on the target anyway. So let's copy all this. Take export non-partition table data, import into partition table. Okay, fine. So now it is definitely going to help our system to improve the performance that we are seeing it part one, part two only it is reading to scan this range. It knows where it falls, and you have indexing also. Even it will make your system much better because it is going to exactly partition exact location. That is the highest level of performance what you can gain on the system. So you think like your partitions are growing too big. Assume a case one of the partition may be becoming bigger or whatsoever, this range is taking more data. I wanted to fine tune into lesser partition, the values should be lesser. You can do it if you want basically. So example, the before that, let's talk about one more scenario to understand this. So if I go to table, this is a simple only guys. So we have four partitions. Data will be 101 to 400, in between only the partitions are accepting it. If I try to load the rate out of range, what happens? It won't take the data, right? Because it doesn't know those values where to fit, where to send. Example 50400, right? 404 example. Assume a case. Then I'm going to give it here, Vinay, just for use case, and address is Hyderabad. If I'm trying to do here, it will throw the error. What is it is showing? No partition of relation of student found a row to accept this. You don't have it. So if the data is not falling under in this range, where it has to go, generally we should have one default partition which should accept all values other than this range. So we should create always one default partition. In any partition technique, we will go with the default also. It's mandatory. That's very much important. Create table, cust default. Let's go. Sorry, default student. Student partition of student. Here default. I'll mention default. So you don't have to mention the range for default partitioning. Okay. So
Ravinder,
now if
just now you exported some data. So what if that data is out of partition range while exporting?
it will fail. You have to have a default also. That's why I'm covering this. If any data is not falling under your ranges, you must have one default that will take all the values which are not falling under these ranges automatically.
So
There
we
is
need
no
to
range
create the
defined.
default.
Default mandatory.
Ravinder,
Okay.
Good.
Ravinder. So if we create the default partition, it will create automatic. The data will flow new data after 400. The records will be coming into the default partition. So
Mm.
in that case, if you don't require a default, if you want to create existing one on a fly, we can create one more partition for the table.
Yeah, you can.
Uh,
Why not? You can create between 400 to 500 another partition you can create if you want to create. But whatever you define, there would be something out of the range, right? That should accept default. Default is mandatory in any technology, in SQL or any product we do. Table partitioning must have a default. If it is not falling under your ranges, it should go to default one. That's how the definition will be. Partition technique. Without that, we don't progress. In fact, example. Let's talk about this. Your case, I understand. I'll talk with a more detail. So, example, I'm covering 405. Example. Just you loaded a lot of data into this partition, and then we realized we need. Oh, that's a big value anyway. 410. So if I do this one, let's make this some more data. 440 something. So default is taking more data as my case because these are all range defined and defined range data is going. Default is the one which is not falling under these ranges. Default will grow very fast because of the ranges wherever it is not falling, it is coming here. So I want to define one more partition, but it is not directly possible. Let's talk about that challenge. Create table student. Okay, cust part 5 student. Okay, partition of sorry, student. The heck, partition of, it's not coming. Create table, where it went wrong. Sorry, this should not be here. It's not resolving that, in fact. So here it will partition of student. Okay, values from, what the heck, is not partition of students. It is not it should resolve
For
automatically when they are
values,
creating the,
for
okay,
values.
okay. Yeah, out of mind. Yeah, for values. So values from 400 to 500. This is going to create the issue actually. Why it is going to create the issue? Because
Already default is early.
it will throw the error anyway. Updated partition constraint default partition would be violating the some row. Why it is violating? Because there is a data and the default which you are trying to partition. So if I go and read, this is actually causing the issue. It happens. How do you resolve? I'm going to talk about because we have to create some custom partitions even later on as well. This is a data range, right? So the 404, 405, 445, these three rows are causing the issue. So we will create a temporarily backup of this one or export and import. Either of will work in fact. Let's export and import I already did. So let's go with other method. What I'm going to do, I'm going to create the backup of this table. Which one? Default partition table. So create table. Table is this and underscore backup. I'm creating the backup as select asterisk from this one. So this is going to create the table backup. Select asterisk from create where it is, or select is wrong. Right. So now if I read the backup table, you'll have all the data of that. Which one? The default table, default one. Now what I'm going to do, I'm going to truncate the default, that one. Truncate. We took the backup already. Okay. You have to. I'll write the notes anyway. I truncated it. Now I'll create the partition. You can come through the export import also. That only the default one. Now I'm creating the partition. It got created because we removed the data. Right. We have. Oh, sorry. Here student. So we have student table. We have 5 partitions and 1 default. Now what I'm going to do, we have the data in the backup, right? In the default backup. So where this one, heck, backup. Here we have the data. I want to load this data into the student table so that this 404, 405, 445 will go to here and 4010 will go to the default because it's out of range. So let's load, insert into, okay, this table. only this table from. Okay. From where? Again, from the backup table. Select from. Insert into select from. That's what I guess. Yeah. So we are loading the data back. I'll write on the notes. Don't worry. Falling row.
You are inserting the data in default.
Wait. It should not go into this one default. I should go into the student itself straight away because it knows the past partitions where it should send the data. Right. This is correct because we should send it to the original parent table. In fact, that knows your partitions of where partitions defined where it should send the data and all. We should not send it to default anymore. Okay. So now what I'm going to do now, if you read the data, so let's understand. So if I read this data, partition 5, 400s will come here. You can see that. If I read the default data, what will be in the default? Only the 4010 because it's out of range. Getting to something?
Got it.
Yes, yes, Chandra.
So when we want to define such
I mean,
things,
a note here, 4,000 is out of range, right? So how it inserted into student table? Should have gone to this way.
student table only has the partition, right? A student table is having the default partition. So all these partitions are tagged under student. Student, when you're loading the data, it looks for all these ranges where the incoming data should fit in. It should, if the values are in this range, it will fit into this partition. If it is out of range, it will go to default straight away.
Okay.
So it's logical entirely. So let me write some notes for your reference. When you practice, you should understand how we did it. If this can
For
be done,
default, no range,
uh-huh.
unlimited is.
Default unlimited. There is no definition. Or whatever is comes out of range, there you create that one. So that's why if you want to create further partitions, you have to follow this. Okay. So what
Okay.
did I do here? So I created a default partition backup, default partition table backup. Then we truncated the data. Truncated. Wait. I have to. Why did we do this? Basically, it was not accepting the data, right? There we need to start. This all went to default, but here when I try to load the data, which is violated it. Where here, right? Updated partition. This one. This is error. First thing we need to understand this. So 400 to 500. If I'm trying to create a partition, this range of data, already loaded in default partition. That's why we are getting the error. Okay. To rectify this, we will follow below steps. What steps? We are doing it here. Create a partition table, the default partition table, create default partition table backup, table backup. How did we create table this backup from reading the data from the default partition? So the default partition data loaded into backup table. We have verified that as well. Then we truncated this. Then we created what partition we wanted. We created it. Sorry. Then we loaded the data into that partition. Okay. That's how this is cleared the issue. Clear? If you have a question, let me know. I'll explain.
Clear.
You set it to four partitions, right? After the fifth partition is default. In case if
No,
default
no, no.
partition
Fifth
goes
part.
to,
God. Please complete your question.
yeah, for one to 100 one, and one not one to 200 to you like this, you four partition created, right?
Mm-hmm.
Fifth one is default.
Mm.
In case in future it will default partition will go, so the range is high, 1000 range means we can repartition the 400 500 to 600 like this.
Yeah. This is what you have to follow again. The same thing, take the default table backup, truncate the default and create the required partition, load the data into actual partition, right? Actual table. Actual table, this will partition your data automatically.
Okay, after backup only.
Yeah, of course, because if you can't truncate the live data, right, you have to take the backup first.
Okay.
You took the backup, so create a table, default backup table. Okay, then
Okay.
we truncated the
Uh-huh.
default partition, then created required partition, created required range partition. Okay, then we loaded the actual data here. Load the data back to student table, which will automatically
Ravinder,
partition
can
the.
we modify the structure of the partition range?
Yeah, you can if you want. So example, what he's saying is you want to define the value from 500 to 700, maybe. You can do that, but that follows a different approach again. Um, we have these partitions. So come on, what I'm doing. So if you look at here, 400 to 500, I wanted to 400 to 600 this partition. You can't do it directly. You have to detach. Let's do that. Good question. So alter table student. Okay, detach partition. Which partition? This is a partition I want to detach. Okay, this is a partition I want to detach. I'm going to detached. So now you go and check here. You have to detach if you want to change the definition. You can't do live when it is attached. It is gone. When it is gone, I want to reattach. Alter table again, student. Okay, attach
So it's a
partition.
downtime data, Ravinder.
It's downtime means that data is not available for the application. There is no great downtime. Detach attach is a 1 minute task. Not even 1 minute. Okay, but this during that time, yes, that will not be available. The partition will not be available for under the table. This is what the application sees. This is object. Okay, this partition will not be available. Yes, you have to have a downtime, but it's not too big downtime. Alter table attach the partition. The partition name is this. Okay, you have to define the values. Definitely have to define for values from 400 to 600. I want to define this time. So you have to do detach and attach, then only you can modify that. Now I go and check the student here. I modified the range between 400 to 600. So
Uh,
this is another good question you asked.
Ravinder, that first one you have done copy to path, right?
Mm,
Export and import, right?
mm,
That
mm,
like after that, when you type select star from student, it will show all the records. So
mm.
that is temporary. It will show, or then later when we insert again, that will move to partition table only, right?
Of course, you have to move to the logical table. It will load when you're loading it from the copy from. You're loading it back. Okay, when you're loading it, knows the range where to fit the data. What is the question there?
Okay. Mhm.
We are loading all the data back, right? When we are loading all the data back, it is loading the record by record. It knows the range where it has to fit because this is already partitioned.
Okay.
This
Yeah. And
this is source,
too
this is
many
target.
Too many partitions also having. Is there any issue on the table level? For
No,
example, one table, 100 partitions or 200 partitions.
as long as you can manage, you can create 1,000 partitions. It's okay. No particular definition, but partition will improve the performance, but it should not become a clumsy for the administrator to manage it. That's another part. Okay.
Yeah.
You should do, but the management should be handled properly. If not, you will mess yourself, the data will mess. So you should have that level of techniques, to understanding and everything before you do it. You can do 1,000 partition in a single table. It will give you a good performance. For sure, it will give a good performance. The problem is the management. If you can do management, you can do 1,000 partitions on a single table. There is no rule that you can have less and kind of thing. More is more good impact, but the management also should be equally managed properly. If not, you will go into problem, of course. So to create new definition for existing partition, we must detach attach the required range simply. Okay, you can't do directly. So we detached and attaching with the required range, attaching the partition with the required definition. Clear? Yes, no? It should be.
Yes,
I
then
feel.
it would be like downtime activity, like detach.
Detaching, yes. A small, it's not a, you are not moving much of data here. You're defining, right? So 400 attach and detach and attach, it takes half minute. Yeah, half minute downtime. But again, it should not claim. Example, it's another good question. I want to show this. So basically, if I want to define the this one example, I want to create partition 6. Okay, partition 6 between 500 to 600. What happens? Can anyone think of it? We already have the partition which is covering this range. I'm creating another partition to cover that in between range. What happens to this partition? Will it accept?
It
Error
will
was
fail.
error.
It
No.
will throw the error. Oh, sorry. What it is saying? No, no, this is not this one. I have to use the other one. Just a minute. Create,
Create
yeah, create table. The partition name, I'll make it as 6. Partition of student for values. Now, this is where we define, okay? From of course, from 500 to 600. So you can't define another range which exists already for another partition. It's not possible. It will throw error. So what you would overlap the partition of this between this and this? You can't overlap another partition. It clearly knows it. You define this range should go to here only, not to another partition. Okay, system knows it. So you can't define a bad partition. It is not possible. It is only go to the default. From the default, you want to create multiple partitions. You take the table partition or export the default one and import it back. Getting, not getting? If you're
get.
getting, we are done. We are
Yeah,
done on the table partitioning. I
But we
mean,
should know the default partition values before we do the
yeah.
partition.
You definitely know, of course, that is a well-planned activity. So what is the count? How long it is going to take? How much time we need to buy from the application? Everything has to be done properly. Okay, we have only one record here. You have to check it. You have to take that partition into, partition table into pre-prod, check it, how long it takes. We have to explain all that. Then only it will be approved. You can't just do on the fly. Okay, we'll play around. You have to do in pre-prod, verify it is working as expected, how long it is taking, everything you have to pinpoint in the change. It is a change, production downtime. You have to explain, then only it will be approved. You can't do straight away. Okay, so if you want to do this one example, let's load some data and then quickly, this is the last scenario I'm going to cover. insert into student example. Student values, I'm going to generate series intentionally out of that range. Generate series. Maybe I'll load 500 to 700. Let's do that. 500, okay, to 700. So what happens if I do this? Basically, 500 to 600 will go to the partition 5. Yes, no. Yes, no.
Yes, yes.
500 to, then if I do the rest of the data, where it will go? 600 to
Default.
700?
Default.
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 Default. Let's verify that. So now how many records I should have here? The same query I'll run, how many I should have?
101.
That's correct. One or two,
Okay.
the range, yeah, 501 went there, okay?
Okay.
601. That's okay. If I go and read, let's read that partition where this partition. So it will include another 100, whatever, 4 or 5 records. So should have done asterisk, count asterisk. You can see this, right? So now I want to split a partition here, 600 to 700 also, assume a case. So this is the last scenario I want to cover. So copy table, the partition table, the default partition, what we want to copy, right? This one. So copy this one to where? Uh, here in this location, physical location, PWD. Simply, I'm going to close this topic, okay? So now I'm going to go custom default. I'm just giving a name to identify default.txt delimiter, comma. We are exporting the data of default first. Okay, here data is generated. You are safe. You have to take that. It's very important. You have to follow the steps. Then truncate. Truncate what? If I try to create the partition of 6, come on, please. D plus student. I'm trying to create a new partition. Create table. You should know this already. We have seen. But anyway, let's do it here. So partition 6. This is a partition of student for values from what values? 601 to, I want to
600.
create this to 700. So what this will do, it will throw the error. This will throw the error, right? Because
Yes.
overlapping values. So that's why I took the backup. Then when I took the backup, what I'm going to do? I'm going to truncate. Truncate what?
Default.
Default. Good. Default one. I'm going to truncate this. Then I will create the required partition. Then I'm going to copy from, right? Copy student, right? From where? From the same location what we took the backup here. That's it. So now it will load the data into student. When it is loading, it load into required partition. Now if I go and read default, how many I should have?
Only one,
One,
one
one
card.
record. Okay, few records out of it. 600. Okay, I would have given 600. 600 I did not give it. So 600 did not go to that one. Okay, getting it. 600 I should have given here when it is all other partition ranges 400. 600 I should have given. So 600 is not falling here, not falling here. So it went to default.
Why
So that way.
700 is there?
700 is there. 701 I need to cover to have the 700 there. Okay, it is that way. So this is how the let's keep all this if you want. Maybe select asterisk from this scenario. Right. Next, I'll go to list-based partitioning.
Ravinder, partition 6 we created series till 700, and why it is showing in default?
701 you have to cover to get that 700 into it. One
I
less,
didn't-
always. Just a minute. I'll talk about that. So what is the question? This why this 700 in the default, right? Where you define this one? Yes, no.
Yes, yes.
So basically it is up to 700, one value less on the upper bound. That is a relation to maintain between the partitions, basically. So where it is ended previous partition, where it started next partition. To have a relation, the next value will go to the next partition, in fact. Partition relation. The last value, one less value, that will go to next partition to have a relation, in fact. This is a kind of a chunk. One chunk is having a relation with other chunk, basically. So if I would have made it 700 and 701, I think like 700. That is a relation it should be. But anyway, system does what it does. Based on the how it understand. My assumption here is it is only the relation. 700 should be defined there. It what? Yeah, let's truncate one more time. Just if you want to see that, let's give a last try and then reload. It will.
The
I'm going to
range,
truncate.
Ravinder, I think the range always accept the lower limit and one less than the upper limit. That
Yeah,
is
that's what
usual.
exact.
Yeah.
That is what I'm thinking exactly. I'm thinking the same. So I'm going to truncate. Let's reload. If that is the case, you can't do anything. That's what it is. I'm truncating this. So now what I'm going to do to get this, I'm going to reload from here. Now let's go and see the default here account. Hey, what happened? The heck? The data is gone. We have the data. Maybe took time. What? Does it matter what? We have the data, right? It's
The
showing the
count
data.
start from
Oh, I'm
From
mad.
this.
Not. Okay. So one less again. So that's how it is. Okay. That's correct only in that case. Fine. Let's go to list-based partitioning. The operations are similar, detaching, attaching, defining the range, default kind of thing, anywhere. Okay. In the list-based, range-based operations are same. So generally list-based partitioning will be created when we want. Okay. When we want to segregate the data based on the what you can say status of the action, status of action. Okay. Region, geographic. I'll explain what exactly I'm trying to talk. I'll give it with a good example. And mm, status of the action or anything, status of action, example, this, etc. How exactly it is, let me explain. See, I wanted to query my data based on the region. If I have India, you have Aadhaar card data. Example, just let's take an example. I want to divide the data based on the state. I will query based on the state only, generally. If I want to query the data Telangana state, I'll use the Telangana state partition separately and I'll use the Andhra Pradesh separately. I'll use the Orissa separately. I'll use the New Delhi separately. Some separation I need so that I will only touch that region data, not other region data. That is one thing. Next thing is the status of action. Let's take about Amazon. Amazon, you order a parcel, assume a case. First, you will order. It will be in the ordered state. Okay. It is dispatched. From order to it will move to dispatch. So the order went out of the facility. Okay. How many are went out of facility? Okay. Then in transit move to one location to another location. It has to move to the destination, right? So every status I should know by the group, by that status, how many are in that state, how many are in another state. I should have absolute, difference when I am reading the data. I wanted only ordered, I wanted only dispatched, in transit, delivered. Everything should be shown in a different partition as you change the status of the transaction. So I don't want to mess with other thing, so that my queries, my system performance will be definitely fast. There, the list partitioning will work better. In fact, let's create one and understand. So we have a student table. I'm going to create customer table or teacher table. Let's create teacher table. Create table teacher. Okay. Here T number. Okay. T name. Okay. RKR 100. T address. Address is the one where I'm going to define it here. So partitioned by list, not range anymore, and T address. And the field on which you want to do, you have to define. Done. Now I'm going to create the partitions. Create table name. Part one. Let's go with part one underscore. It's partition one, part one in the sense. Teacher. Partition of teacher. For values in, you have to define the in. Example, TG Telangana, AP. Let's make it this as a South states. South, maybe that will be easy. All South states should come to this partition simply. Just one, two examples. So South part one customer here. I created this one. Then North. Let's go to North. Here I'll make it New Delhi example. Okay. And UP something, whatever it is. Okay. Then West states. Maybe I'll go to West Bengal, Orissa, right? OS, whatever it is. Just I'm defining it that. Then what left? East, right? East partition here. East can be Maharashtra, right? In terms of geographic. Okay. And it can be Rajasthan, Rajasthan, whatever it is. So now we created a region-wise partitions. It is straightforward, just like what we have done in the range-based partitioning. There is no great difference. Definition, based on definition, I'm going to insert data, insert into teacher values. When I'm defining the data, one example, just example data here. Okay, let's take Vijay here. Now I'm giving the address here, AP. Okay, so where it belong to. It's other data, so I am loading it. So next I'll go to here. Let's go with whatever it is. So here the value, let's change the value and the state. Here, what are the values? UP. Then here 3 AP. Then here 4 ND 5. Just example only, guys. Try to understand. It is very you can't go with the range base with this kind of requirement. So you need to understand before you do it. Okay. Partitioning is something you need to understand which one should fit what requirement. I'll conclude anyway by the end of the class. Right. Now, if I go and read the data is like this. Right. Now, if I go and read each partition, it will go into respective. If I go and read, select asterisk from. So whatever the states are falling in this, it will be there in that partition. Absolutely. It will not take any other data. So you see that data got segregated region wise. So geographic wise, anything such sort will go into list. This will improve the performance, obviously.
So physical data available in partition
Right.
table.
Your physical data only in the partition table logical, it's not at all physical. It is only when it is a partition table, it is absolutely logical. It exists only at the product level, no at the hardware layer. Only the partitions will exist. Partitions will actually maintain the actual data. Getting? Yes, no.
Yeah.
Okay, fine. So this is how it is. List nothing else I have to talk here. The rest of the things are you want to build a default example, the same thing. If I want to go with the
Ravinder, what about if we have the indexes on the table with
index is
when we are doing the partition?
ev- see, index is something every table. This is like a table. You don't index on this one, you index on this one, partition. Because partition is the one which takes the, you can index on the table, on the parent as well, of course, you can, because the fields exist there. Let's go on.
Why I'm asking is because indexing will do the performance better. Again, if we are dividing, I mean, taking the partitions and having a index
That's mandatory.
again.
No, I'll come to your point. So where we are actually our maximum, filter is going on address. So create index, index name IDX, table name is teacher, right? So then on table, what table this and what field? Address, T address. So you create on that field. In fact, this will be the best. You partition, you have index. This will give the super fast performance. Okay.
Okay, there will not be any, confusion or that kind of thing because
Indexing is
it will
indexing.
first check the index. It will check the first index and then it will go to partitions, right?
Right. So if I am reading the data, let's read this example. This is what anyway I was trying to show. What the heck? Every time I'm forgetting this. See this. Understand this concept, please. So if I'm reading part one, okay, I am getting only one record, but in the background also it'll read one record only. Explain, analyze. Why it will read one record? It is goes to that required partition only to read. It won't go to other. It knows where that data is in fact, because you're given a condition, right? Um,
Mhm.
Explain, analyze part one. Part one anyway, it will go there. Just a minute. I want to go give a different condition. So where let's read the data once. I, customer. What is the table name? Customer only, right? Why it is not resolving? Teacher. Okay.
Teacher.
So now select asterisk from a teacher where, okay, t address, this is where we need to give a condition in, or just equal to, also give it, not an issue, equal to up example. So if I give this one, which one it should touch? This is the one, right? North part, partition of north. Yes, no.
Yeah, yeah.
Explain, analyze. It will only read the north partition. That's it. At the same time, you use index also. It is a very less data. It is only the sequential scan. So if you have more data, more than maybe hundreds, some hundreds, then only it will take the advantage of index. See, when the table is small, you create index. Index advantage will not be taken. Why? Because going through the index is expensive than reading it entirely because it's small.
Oh,
That
okay,
is
got it.
system thing. Okay.
Yeah, yeah, understood. So it will touch the partition first, and then it will again
Go
filter
to the index.
depending on the primary.
Yes.
So it will advance. I mean, advance the search very fast. Okay, and
Yeah,
one more
yeah.
thing: can we create a partition to the partition? I mean, like sub partitions.
Of the this one again? No, you can't.
Yes.
This doesn't exist any structure. The structure depends on the parent table, right? See, when we are creating the partition, we are defining any structure. The it's
Okay.
physically attached to that. You can't create the subpartitions. No.
My doubt is like if we partition by year first and then partition by month under that, that's it is not possible. You are saying, right?
You have to create in the beginning as a month itself, not as a year again.
Okay.
You
Okay.
can't because this doesn't have a structure. When we are creating the partitions are actually referring the parent table. If you look at the partitions, how we created here, when we are creating a partition, did we define any definition? No. Definition coming from here. If you want to create the subpartition, it has to have a definition. It doesn't have that way.
Okay. Okay. Got it.
Ravindran, to add on this with Vinay, see the partition of a bigger table. So
Mm,
if it is a data warehouse where the
mm,
data will be coming up yearly basis, based before coming to the database, it will be in a monthly basis. So
mm,
once the data will move to the data warehouse, we can have a year-wise data. So in that
mm.
case, the copying of data of a year-wise, so will affect the existing partitions? Why? Because in data warehouse, other database where it was partition was there based on the year wise. If you
Mm,
move the data from
mm.
OLTP to data warehouse, where
Mm.
the data was having the partition was having every year, in that case, what will happen? Is there any
Nothing
conflict?
will happen. OLTP month wise, OLAP year wise. You load the data to here, it will be loaded into years partitioning. When you load the OLTP, then it will monthly. So every table has its own definition. So where the relation?
Okay, okay, it's a logical only. It will not reflect the
Right. Here you have
database.
created in the OLTP the monthly partition. Every month
Right.
has its own partition. Here you define all the year-wise partitions. It is table. So based on the data, what is inside coming, that will push the data to where it want to. So this simple.
Okay, okay, got it.
Okay. The last thing I want to talk about hash-based partitioning. So the rest of the things, whatever I discussed here, it applies to the list also, removing, adding. If you want to add some more states, I have to detach and attach. When I'm adding it, I have to give that new state. Then the definition can be modified. If quickly, let's do it. If you want to see that, maybe here, come on. Teacher, right here. I want to give West Bengal, Orissa, Meghalaya, whatever it is, that west side. So now if I want to do it, alter table, teacher, edit
Ravinder,
and
for this list, there is no default partition, right?
you can, oh come on, you can create if you want to create table, okay, default, everything should have a default. I was just talking about default part or the default partition teacher, whatever it is. You should create, in fact, okay, partition of teacher, uh, okay, for values default. So here default we had to write So you create a default partition. Of course, you can create, everything should have a default. It's mandatory. We must, because when the data range is not falling here, it should go to default. Any partitioning technique, you must follow the default except hash based. Hash something I'm going to talk about next. Hash no need to have the default. I'll talk about that next. But the range based list based must have a default partition associated with that partitioning technique. It's mandatory. Okay. You should not fail any transaction just because of the partition. So every partition, any list or range based partitioning must have default partitioning accept out of range data. Simply, always, always should accept. Just because of the partitioning, you can't reject the data. Okay, that is not a business. You can't give that as a business justification. So, any questions further?
Can you do like one attach and detach for this list like
Yeah,
copy?
okay, let's do it. Okay, alter table, teacher partition, detach partition, detach, detach partition. Which one? This one. Let's do this. I'm detaching the partition. It got detached. Teacher. Now alter table. Table name is teacher. Attach partition. The partition name was this. What we detached. Right here for values in. What are the part? You have to define everything again. What we had, which partition it was west, right? West, this one. So this along with this, I'll go with the MG Meghalaya, whatever it is. I'm just, what is the short form is I'm not sure, but I'm just giving Meghalaya kind of. Okay. Now I'm define, I'm attached it. Now you go back and get that definition added. Clear?
Got it.
Fine. Let's move to hash based last. Hash based partitioning. This is a very special one. So if you understand the concepts, very, very simple. If you make things complex yourself, then it will be complex. So understand it. Understanding is very important. How we operate, what kind of decisions, when do we take, and all that. Okay. Has based, like partitioning, when it will be done, when there is no criteria. I just want to distribute. That's it. There is no grouping like list kind of thing. Range. There is no range. I don't need this. Just I wanted a partitioning without any conditions. That's where the hash based partitioning come into picture. So hash based partitioning will be helpful to partition the data, to partition the data without any particular field, any particular field. Um, it can be done when we don't keep any criteria, uh, criteria. For data partitioning criteria in the sense, I don't need the state wise, I don't need the range wise, I just need the partition. I'm not define. Let's do it. I'll make the notes later on. You understand through the practical the entire thing. Okay. Let's create. So we have teacher table and student table. I'll create the customer table then. Create a table customer. Try to follow. C number, integer, C name. You understand what I'm going to explain. Based on that, you figure out the why it needed, kind of. So C address. Right. Partition by hash. Hash on what? C number. Generally, we keep it as numbers. So we are creating on this. What the? Oh, this spelling wrong. Created. Now, how I want to divide the data? Divide the data based on the divisible numbers. Hash is something. Let's create the partitions. Then I'll explain. Create a table. Okay, table name is maybe again part one customer, partition of customer. For values here, you have to define like this. Mm, Modulus. How many partitions I want in this? 5 partitions, 4 partitions. You should know that thing. Based on that only hash partitioning will be defined. I need 5 partitions. My data is 1 TB. I want to divide my data into 200 GB, 200 GB, 200 GB. Close to. Maybe here and there, few MBs difference will be there. I don't have any criteria, but I want to divide my data simply. 200 GB, 200 GB, 200 GB, 200 GB. 5 partitions I wanted. Maybe 4 partition, 250 GB, 250 GB. You have to understand before you create the partitions. Once the partitions created, not like other thing, it won't work. You can't attach with the required thing because data is already distributed. It will be problematic. For hash based sharding, you have to do partitioning beforehand. For list based, range based, you can modify anytime you wanted. In the hash based, it's not like that. So you have to have a proper planning before you implement the partitioning. So how it works, then you understand. Uh, Modulus 4 partitions I want to create. So based on the number of partitions, you have to define the value here. 4 partitions, 4. Then if the value of the remainder is 0, come to this. Okay, what it is saying? Modulus.
Remainder spelling wrong, I think.
What
Remainder spelling.
remainder oh, correct. Still modulo or modulus, I'm not sure. Mm, let me see the syntax once. Syntax I wanted. Just want to see once how it modulus. What I define, right?
With, I think so. With values with.
With is there values. Okay, 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 fine. Good, good catch. So now here, come on, this is customer, right? So we have 1 partition. Now I want to create other 3. So this
Ravinder,
value,
can you explain this like customer for values modulus 4 and remainder 0?
wait. Just I'll load the data and explain because we did not load, right? You don't understand directly this thing. I need to show it, then only understand. Okay, then 2. What the heck I'm doing? I need to change this one also. So it should be 3 only, should not go up to 4. 4 partition 0, 1, 2, 3. Now D plus teacher. Is it teacher or customer? Customer, right? So here, look at this table structure. I have a value. The value, if it is divisible by 4, it becomes 0 as a reminder, then it will come here. There is no range. You have the value in the C number. We have partitioned based on the C number, right? When I created this one, let me make the notes here. I created this, then I created partitions. First partition, where the first one 0, here it is. Let me make the notes clear because there are many errors went through. It's a distribution of data based on the modulus. There is no range. Range is, we don't define for this, doesn't go with the range, it is going with the distribution. Let me explain this. Let me open, let's see, reminder. Do we have any such thing? Because you don't understand orally. We have here, good. Let's see. Example. A dividend means the value. The value, actual value, what I'm entering, C number. If I make C number 10, assume a case, then I'll give the actual modulus is 4. So what will be the reminder? 2. Where it will go? Reminder 2. Here it will go. The data.
Part 3.
Come on, please. This one. This is it will follow through in the background hash value, but that's how it works. If I go with example, some random number, not it should be number only, not example. This is a number. Where it will go?
Part 1.
This one. So if I'm giving some any random number, so this one, where it should go?
Last one.
Last. That's it. That's how it works. Reminder mean. You load your data, you create your partition. There is no explanation for it. It is directly internally it does. So insert into, now understand, insert into values.
If we do the hashing with string, how it will be defined? How it will be calculate?
It works on numerics. In fact, the modulus, it's a modulus, modulo.
Oh.
You should divide some value. Okay. Just a minute. I got a page here. 1 minute. What it is. Okay, fine. So it's a value. You should doing the modulo always will be on the module, not on the text. It's a numeric because you can divide only the values. Okay, I had to write that one notes. It it can be done, and it can be done when we don't have to keep any criteria for range of values. Next note is we must implement partitioning field will always see numeric, always field always numeric, because we divide the data, divide the data based on the division. Division only can be done on the values simply, right? So this is how it is. So if I go load some data here, generate series, it's something you can't predict how data distributed. I'll give it here, Naveen. So I'm loading it into the 100 cards loaded. Now you have your own partitions. Let's read one by one kind of. select asterisk from, let's asterisk from this. You have this, what?
We inserted data into different table.
Oh shit, thank you. It
Customer.
should be customer. Okay. Customer, because it is matching with the other one, so it went through fine. Good catch, thank you. So you have here the 27 records. So roughly here and there it will be close to, the distribution goes equal, in fact. Okay, where it is customer part 2. So there is no range here. Okay, so 31 records part 3, 25 records part 4, 17 records. So it divides your data based on the value and modulo. That's it. There is no range defined for it. Your values will only fall under this. There is no default. You don't need it. Always a value divisible by 4, and what is some reminder, because you said you want to have 4 partitions, then you have to define that one. Okay, if you want to change the structure, you have to create a new table with a new hash partitioning, take this backup and load there. That's how it is. You can't alter it. Hash partitioning, we can't alter it, just like what we did in the range and list. It is straightforward. But here there is no value range we are defining it. There is no, we want to just divide the data. That's it. There is no like range kind of queries, or grouping kind of queries we are doing geographical, what we have seen in the list and range. It is just a requirement, you want to divide your data, not in a specific condition. First two cases are conditional, range based, and only the geographic based action of the event. Basically you want to group on something values, then the second list will work better. Okay, because you are grouping on similar objects. Maybe you have a department, which department you are going with grouping, there will be always a grouping will be done on particular column, right? Then the list based will help you a lot. Range will be when you're reading the range. This is something purely divide the data. Simply I want to divide my data without any condition. That's where hash works.
So in real time, like which partition goes for?
Mostly
In
we
real.
use range. A lot of times I have seen practically range. List also I have seen, hash also I have seen, but mostly comparatively the most used thing is range generally, because range based queries OLTP they use more than others. Depends again. Nothing is something you can say this is only the ideal solution for everything. No, there is no such thing. You have to understand the criteria, what they're asking, what kind of data you have. If it is a range based, maybe date range, what range they will go with. The date range means you have to go to range based partitioning on the date field instead of numeric. Okay,
Okay.
so understand the situation and call the partitioning. You can't say that this is absolutely the ideal solution for every scenario. No, but we need to understand. Clear? If you want me to show in 2 minutes, I'll show the date range thing quickly. Maybe if you really want. Uh, where it is, where it is. List. Okay, yeah, here I'll make. Range based partitioning. Part 5 minutes. I'll close this topic. Partitioning on date range quickly, because maybe because this is also a heavily used partitioning, so you should know it. It is simple and straightforward what we discussed on the range already list, but anyway, you should know it. So I'm going to create a table, teacher 2 example table. I don't keep it here. Then teacher name, where 100, date of joining, teacher date of joining. Okay, date I want to give it. Okay, Now we created this. Now I'm going to create table or create table part 1, whatever it is, underscore teacher, partition of teacher, for values from 2020. Let's define starting year 2023, first 1 month, January 1st to, it should be 2, but is not coming to what?
Teacher 2 and one more thing is equals to you kept.
Oh,
Partition of teacher
come
2
on.
for values.
This is not anyway syntax. It won't look because that's in the quotes. 2023, quickly, exactly 5 minutes, please. 12th month, 31st. This entire year should be covered here. Oh shit. What is the problem
Partition
Name,
here?
of teacher 2.
name not given.
No. Partition I did not define on what. Should drop it. Drop table. I did not define it as a partition table, okay? Here. Partition by what? Partition by range. On what? T D O J. This is a field. Right. Now I'll create the partition. Values.
Yeah, T name not defined.
Why you have to define so partition?
Table name
Right.
teacher 2.
That is what. Good. You guys are, having some concentration on the class then. Okay, good. Let's go to this. Here I'll make it 2024, January to 2024 last. Okay, second partition. Third partition 3. Here 5, 25, right? The new year. So all should come here. Right. Now you go and check the teacher 2. Yeah, teacher 2. These are the partitions. Default also should have it. I'm not giving it. You should create default means how you create default. Default, right? So you create default. It comes there. Partition default. This one. So default must exist. Don't forget that. Okay, you have it. Now insert into teacher 2. Okay, values of course. I'm just randomly taking. Date of joining here is 2023. Month is 8th month. 8th month. Date is 23. Whatever it is. Now I'll make it here 24. I'll make it here 9. Make it here 5. I'll make it here 22. 22 we have 23. So now you go and read. Select same, just like what we have done on the range. So now again, if I go select from right here, see all these are all falling under 2023. 2 is all falling under 24. 3, 25. Simply is all about it. Date range if you just want to practice. Okay, that's all. More than enough information, I would say. You do all this, you're done almost entire partitioning. So you just need to understand the concept, guys. Then you can logically connect and give the solution for anything. So that's what you have to do some practice. You can easily do these things. Okay. stopping it.